All right, so now we're going to look at geometric. We just looked at arithmetic, which was similar to linear. Now we're looking at geometric. Before we start, we're going to fix this pattern. I copied the wrong pattern on there for you. Could you please cross out one circle? So just kind of black that out so that it's not there. Geometric sequence is similar to an exponential function. Exponential. Geometric sequence is a sequence of terms that has a common ratio. Right? What that means is that you are multiply by the same number each time. Okay, so that's what geometric or exponential functions mean. Let's take a look at the formula for geometric. So we've got exponential, geometric, explicit. So it's the second one right here. So it's going to be a sub n is equal to a1 times the ratio raised to the power of n minus 1. Okay, so again, let's go over what everything means. Your a sub 1 is your first term. What is that similar to when you're looking at a function? It's similar to your start because there's no plus c here, so this is your y-intercept, right? So again, in functions, we start at the y-intercept, but in sequences, we start at my first term, okay, where n is equal to 1. All right, so that's that. My growth is like my ratio, okay? So let's go ahead and define this again. So this is my first term. R is my common ratio. And again, that is my growth or my decay. So it's how I am growing or how I'm decaying. And then your x is similar to n minus 1. Okay. Your recursive formula, which is this one right here, is a sub n, which is equal to your common ratio times the previous term. So remember, again, this is very important. A sub n minus 1 means your previous term. Okay, R is your common ratio. All right, so let's look at a sequence. So I start at, how many circles do I have right here? Let's count them. You have 4. How many circles do I have here? 3, 6, 7, 8. How many circles do I have here? 4, 8, 12, 16. Okay, so this is my first one, my second one, my third one, right? So my term is 1, or this is n, is 1, it's 4. When it's 2, it's 8. When it's 3, 16. And now, because this is a common ratio, I am multiplying by something each time to get the next number. So what am I multiplying by, and how do I find it? So instead of doing arithmetic, which was subtract my common difference, this one is a common ratio. And when you have a ratio, that is a fraction. So it is y2 divided by y1. That's how you find it. So your second y value, which is 8, divided by your first y value, which is 4, and this is 2. So if this is correct, if this is a common ratio, you should be multiplying by 2 each time. Is that what I'm doing? Yes. So how do I get this next term? 16 times 2, which is 32. If I multiply that by 2, do I get 64? I do. So this is the 4th term, 5th term. Now you're going to find my 10th term. Does it make sense to connect the dots in the graph? Is it continuous or discrete? So let's go ahead and graph it first. So from the table, 1 is 4. So we're going to go to 1 and 4, put a dot right there. Then we're going to go 2 to 8. So 2 to 8, put a dot right there. 3 to 16, put a dot right there. 4 to 32, put a dot right there. 5 to 64, put a dot right there. All right. So now the question's asking, basically, is this continuous, which means I connect all the points, or is it discrete, meaning I just leave it just the way it is without connection? So the way to understand this is whether you can have whatever is in between the dots. For example, in this example, can I have 1.5? Okay, so here I have a set of sequences. In sequences, it always goes 1, 2, 3, 4. There is no in between. So in this case, does it make sense to connect all the dots? No. Therefore, that makes it discrete. Okay, so no, I cannot connect it because 1.5 is not possible. So once again, in order for something to be continuous, everything in between my coordinates, so 1.5, 1.7, 1.9, everything in between my coordinates has to be possible, and that's why you can join it, because this is possible, this is possible, this is possible. But in this case, it's not possible, so therefore it does not make sense to connect the dots. Now, with that being said, what is my domain? We know my domain is from my left to right. Is it possible for me to have -1 in a sequence? No, it is not possible. So we know that the negatives don't matter in this sequence. And then also decimals don't matter. So it can only be, and can I have 0? No, because it always starts at 1. A sequence always starts at 1. So I can't even have 0. So I can just say my domain is all positive, and I can say integers, whole numbers. It just depends on whatever they use in the questions, integers / whole. So I'm going to put both just in case. All right, in terms of my range, what is my range? So even in my range, I can't have 4.5. I can't have that right here. I can't even have 5, to be honest, because it's not a dot. So this one is not all positive whole numbers. It's a particular set of numbers. So my range is really 4. So my range is such that x is 4, 8, 16, 32, 64, and so forth. All right, because I cannot include 5 because it's not defined, because after 1 it has to be 2, which is 8. So again, range is just what is possible from the y-axis. All right, so we're going to go ahead and write the explicit function. So let's start with the formula. So again, you get this formula right out of the formula sheet. So it says a sub n is equal to, and then it says my first term. So what is my first term? It's what happens at 1, not at 0, at 1. So my first term is 4, and you can get it from a pattern. You can get it from a table. You can get it from a sequence written out like this. They're just different representations. But my first term is 4. And then we're going to multiply that by the common ratio, which we can find by doing y2 divided by y1. Or alternatively, we can also just put that into the calculator. So while I'm here, I'm just going to show you that as well. So I've typed in the sequence into a table. We're going to come here. If it was linear, again, we're going to hit zoom fit. It would go perfectly through every dot. Because it is not linear, we've also done quadratic. That would also need to go perfectly between each dot, but it is not quadratic. And the only other one we deal with is exponential. And you can see that it clearly goes through each dot. So this is my function. So I'm just going to copy it right there so that I know. So my common difference, if this is my function, remember it goes a, b, and then x. So my common ratio is my growth / decay, which is b. It's exactly the same. I don't have to change it. So this is going to be 2. And then after my common ratio, I have n minus 1 as the exponent. So n minus 1. And sometimes you do need to put this in parentheses, because especially if you're putting it in decimals, it's not going to stay. Well, I'm not even going to show us how to go from explicit to function notation, because you can clearly see we've just done that. Put in whatever the sequence is, click the flag button, zoom fit, make sure it fits perfectly as to what you're choosing, and then there's your function. So my function notation is going to be f of x is equal to a, which is not the same as a1, the common ratio, which is b in function notation, to the power of x. So again, the only difference between sequences is that this one starts at 1, whereas when you have function notation, that starts at the y-intercept starts at x equals 0. So I'm going to say, I guess, x equals 1 on that one. Okay, so be very, very clear about the difference between a sequence and function notation, because it'll also help you write it. Finally, the last thing is let's write our recursive formula. What is our recursive formula? A sub n is equal to your common ratio times your previous term. So a sub n is equal to your common ratio, which we've agreed. Common ratio and b is the same. As a matter of fact, I'm going to go ahead and write that. Common ratio is equal to b. Please do not forget that. Your common ratio and b are the same thing. So it's equal to your common ratio, which is what? 2. All right. Times your previous term, which is a sub n minus 1. Let's practice.